you find x-intercept. Set the function equal to 0. Thank goodness, I think this one does factor. And you could use quadratic formula. But I'm hoping, I'll save you a little time, it factors and looks like, quickly. I think those are the factors. Then split this up, it's called a zero product property. Take your time to do this. Guys, if I take my time, we're going to end up with x is equal to 1/2, easily done. And we'll write like this since I'm talking about an x-intercept, an ordered pair. And here, of course, we'll end up with x is equal to a -2. And there's the other x-intercept. Now be honest with me. Let me see by a show of hands. How many students got those two? Oh, feel better. Feel better. Those are the x-intercept. Now if I ask you before I close down before the break, if I ask for this one's a little bit easier to find. The y-intercept is merely you go back, and I'm short like this. You go back and replace all the x's by 0. That's where you find the y-intercept, or the y-axis. If I go back here, the period says, please be patient, and replace those x's by 0. And professor, I'm going to get -2. So my y-intercept as an ordered pair is going to be written like that. Equivalent. So now I know my x-intercept, I know my y-intercept, I know my turning point, my vertex, and this thing is going to open up. I know everything I need to get a graph of the function itself. Hey guys, we'll do this, and then we're going to take a break here. Hold on. Let's see what this may look like. Okay, on the grid, this x and the y. Okay, guys, I'm going to plot these first. 1/2, 0. Some numbers on the grid, just get ready to go. Okay, my x-intercept one was 1/2, 0. Let's place 1/2 right here between 0 and 1. There's an x-intercept. Another x-intercept is -2. I have that marked. That's an x-intercept. The y-intercept is down at -2 here. Now, let me put in the turning point. That should be enough to sketch it. Guys, the turning point, hang on. What's this string saying? This is my vertex. I need to plot that the best I can, approximate. Move out -3/4 and down, 3 1/8. Okay, -3/4, close to a -1, right here somewhere. And then drop down, what was it again? -3 1/8. If I drop down -3 1/8 from there, extend my graph down just a little. Call that -3, this is -4, and we'll have the graph down here. The guy's -3/4, close to a -1 up there. Drop down -3 1/8. Is it right in there somewhere? This is my vertex. Is it? Close to? Now, what was it again? -3/4, down 3 1/8. I have mine, something like that, from a vertex. Now, do I have enough to connect and get the graph? The graph should be opening up. It's going to come down something like this. Pick that vertex up, that's my turning point, come back up. Pick that point up, pick my x-intercept up. Is that reasonable? The way it's marked? Yes or no? I did it quickly. Did we pick up all the points I need? Did we, guys? That looks great. And there's the graph of that function. Now, I know it's almost break time. Do we accept the graph? Now, on the side here, I just want a quick response. Here's the function. Anyone now tell me, with a quick response, I've now changed this to an inequality. Did you guys have some inequalities on that exam? And you had to use what, sign analysis? And some students say, Professor, I like sign analysis, but I don't quite understand sometimes. You gotta do what test number, you gotta check this and check that, and see what signs you have. Can anyone tell me, be clever, then we'll take a break here. If you have a graph staring at you, no sign analysis is needed. Nothing's needed but your eyesight. Can anyone tell me, based on what you see up here, how you're going to solve this and not worry about it, not touch sign analysis, not touch factoring, not touch quadratic formula. All you need is a keen eyesight. Go for it.
We can just remove the graph above the
No.
x-axis.
I'm not gonna flip anything. Tell me something before I take that break, because we deserve a good break here. Yes?
Anything underneath the negative y?
She says, Professor, get real. No sign analysis. If this is this picture, it's graph, you're looking for the piece below the x-axis. The piece of the graph below the x-axis, here goes, guys. All this on that parabola is below, as she's telling me, below the x-axis. That represents negative. That's why I wanted this simple set, look for negative, below. Now, can you tell me where is that happening?
In between the negative 2
Thank you.
and the 1/2.
Oh, I love it. Mathematician over there. That's your answer. That's your answer. No sign analysis touched. It's based on the graph. Thank you. Hold on. You will take a break. These questions, let's do this one, then we'll take a break. Anyone now tell me, without sign analysis, based on the graph, how can you find the answer, interval notation, real quickly, and don't touch sign analysis like you did on the exam? Anyone? What are you going to be looking for now? What do you think, greater than or equal to 0? Jonathan, might mean for me to look at since I have the graph staring at me.
Negative infinity.
No, tell me what part of the graph are you looking at?
Oh, above the x.
Above.
And the intercepts.
Thank you, right here, and it's above. Right here, and above. Those two pieces are above the x-axis, which implies what you want, greater than 0. And he says, Professor says also equal to, so I can actually include those two x-intercepts. Jonathan, tell the class what that would look like, and we'll take a break here in interval notation.
I believe it's parentheses negative infinity to bracket -2.
Love it.
Union bracket 1/2 to infinity.
Look at that. There's the answer. Sign analysis not touched. It's based on the graph. Would you guys prefer me next time I ask you to find or solve a quadratic inequality? Would you prefer maybe I supply the graph with it right on the side? Show you what the graph looks like? And then ask you that question? Wouldn't that be cute? Which is true though, that's what happens. So you guys take your well-deserved 15-minute break. Okay, I see what time it is.